Welcome to SCA's webinar on Reliable Technology Rule with Dr. John Lee. Before we start the webinar, we'd like to conduct a poll. We have a number of people who are joining us today from around the world. So we have a few demographics questions to ask you. So as you see the first question, how many years of full-time experience do you have in the oil and gas industry? So we'll take a few minutes for people to join that. All of you who are joining the webinar today should be muted as you join. And so we'll be using the webinar features to post questions. So let's share this first question. It looks like we have a broad spectrum of different experience levels, all the way from less than 1 year, and then certainly in each category we have a good representation up to over 30 years experience. So our next polling question is related to how many years of full-time experience do you have in this topic? So our topic today is on SEC's Reliable Technology Rule. Where are we today? So this relates to the PRMS and SEC reserves and resources regulations. And Dr. Lee will be giving us information about reliable technology. So please give us your feedback as to how many years experience do you have in SEC reporting and reliable technology. And so let's close that poll and share the results. Again, we have a broad spectrum experience. It looks like we have more people in the 1 to 10 years category than anything else. 63% of our audience has 1 to 10 years experience with this particular topic. So it looks like we'll all learn something today from Dr. Lee. So our next question is related to discipline. And what is your primary discipline? Petroleum engineering, facility engineering, geoscience, petrophysics, or other? So we're getting feedback now. This should be a quick response. All right, so I'll go ahead and close that poll, and we'll take a minute to share those results. 81% petroleum engineers, and then we have some representation in geoscience and other as well. So we have one last polling question. So let's go to the last polling question. And in what region of the world do you work? So tell us a little bit about your demographics geographically, and let us know where you work. All right, we're starting to get the responses on this one. It's lunchtime in Houston, so I would expect we'd have a large percentage from North America. But let's take a look and see. The results are, yes, 89% from North America, but we do have some representations from other parts of the world. And we will have this webinar recorded, and so after we complete it later this afternoon, you will receive an email with a link to how to watch this webinar in the future and share it with your colleagues. And you will also receive in the email a link to register for the 2-day class that Dr. Lee will be teaching in both January and May on the PRMS and SEC reserves and resources regulation. More information about that soon. So I'm going to share my desktop here, and we have a few slides. This is the webinar. You have joined today Dr. John Lee on the SEC's Reliable Technology Rule. Where are we today? And Dr. Lee needs no introduction, but he is a professor at Texas A&M, received his education from Georgia Tech, and has been involved early in his career at ExxonMobil, where he worked in reservoir engineering, and joined Texas A&M as the Regents Professor of Petroleum Engineering. While he was there, he also did consulting with Holditch and Associates in unconventional reservoirs. He's been an academic fellow associated with the SEC, particularly as they modernize the SEC rules for reporting oil and gas reserves. John recently had a stint at U of H, where he was the Cullen Distinguished University Chair from 2011 to 2015, as they were launching their new bachelor's program in petroleum engineering. John has authored 4 textbooks, which are published by SPEE, and he's won the Lucas Medal, the De Goyer Medal, and he has honorary membership in SPEE, the highest award honored to SP members. He's a member both of the National Academy of the United States and the Russian Academy of Natural Sciences. So today, John will be giving just a short sample, an hour, of information related to reliable technology, but this is a sample of what you might learn if you attend his class that will be held. We've got dates in both January and May scheduled so far this year, and of course John could teach this class at your location as well. So there's more information there. And SCA is a global firm that offers consulting, direct hire services, studies, and training. And at this point, I'm going to pass the presentation rights over to Dr. Lee and give Dr. Lee the rest of the time.
All right. Thank you, Susan. Good day, everyone. For most of you, I see from our poll, it's noontime. What I'm going to do today is give you a single topic out of the many that I will cover in the 2-day short course, which I'll be presenting in January and then in May in Houston. Our topic today is the SEC's Reliable Technology Rule. Where are we today? This presentation is based on a paper that Rod Seidel and I wrote and presented at the HEES, that's the Hydrocarbon Economics and Evaluation Symposium in Houston in 2016. But this is one of the most often topics of, it's a topic that's most often of interest to those who are trying to keep up with the SEC's reserves, reporting definitions, and then the reporting requirements. So in our work today, we will present first some background on reliable technology for those of you that have not followed development of this topic since the SEC presented its modernized rules to the industry in late 2008, early 2009. But we're going to look not only at the rule itself, but also in this update, we're going to examine recent literature on reliable technologies. And then we're going to present one technology which has not yet been published except mentioned in the paper by Rod Seidel and I that I referred to a moment ago, and that's taking something that has been published but expanding on it, specifically expanding a geological modeling statistical method into 2 separate component technologies. Following this presentation of material on reliable technology, I want to share with you some comments from the SEC to reserves filers, and these comments I think will give you some additional insight into exactly what the SEC expects a filer to have done when the filer bases reserves estimates on what the filer claims to be reliable technology. And after we've done that, I will wrap it all up with some brief conclusions. So let's start with a very important question, urgently important to those of you that really haven't looked closely at the SEC's rules. And the question is, what is reliable technology? Well, the SEC's final rule, that is its final set of definitions and disclosure requirements, which it issued in late December 2008, that rule states, and this is definition number 25 from the SEC's list of definitions, and they said that reliable technology, it's a grouping of one or more technologies, including computational methods, that have been field tested, has been demonstrated to provide reasonably certain results with consistency and repeatability in a formation being evaluated or in an analogous formation. Let's look at some key ideas within this relatively short definition which the SEC has issued. Reliable technology, first we note, must have been field tested. If you want to claim a technology is reliable, it must be more than just a bright idea based on what you believe to be sound scientific principles. You must have applied this technology in the field a number of times. And in these applications, this particular technology must have been demonstrated to lead to the correct conclusion the vast majority of the time. And this application, it needs to be in the formation or the reservoir within the formation that you're currently evaluating and for which you wish to disclose reserves, or at least it must have been applied repeatedly in an analogous formation or reservoir within that analogous formation. Now, I'm not going to elaborate on the requirements for analogy here today. I'll simply note that the SEC, in another of its definitions, has specified the criteria that are required for one reservoir to be analogous to another reservoir. All right, the next question that we might ask is, okay, so we have a definition of reliable technology, well, what's its value? What can we do with it? Well, the best short answer I can give to that question is this. Reliable technology allows us to claim exemptions to much more rigid, much more prescriptive reserves evaluation guidelines. Let me give you two examples to further illustrate what I'm talking about. The SEC says in its definition of proved reserves that the proved area for hydrocarbon reserves extends down only to lowest known hydrocarbons. However, in that same explanation, it also presents a possible exception. And the exception is unless reliable technology establishes reasonable certainty of a contact at a still lower level. Now, lowest known hydrocarbons are ordinarily identified with a drill bit or with a well log following drilling. In a well that we have drilled, we can establish that hydrocarbons are present in that reservoir down to a certain depth, but we don't have any proof that the hydrocarbons extend to a greater depth. The potential here is that reliable technology may allow us to establish with reasonable certainty that we have hydrocarbons down to a lower depth. That allows us to report an increased volume of reserves that we can claim to be proved reserves. A second example, proved undeveloped reserves, or PUDs, the acronym is commonly used in the industry. PUDs are limited under the rules to immediate offsets of a given well. But again, there is an exception that's stated in this part of the requirements for PUDs, and the exception is you're limited to immediate offsets unless reliable technology establishes reasonable certainty of economic production at greater distances, that is, further away from a well than just the immediate offsets. How far away? As far away as you can establish using some reliable technology the reasonable certainty of economic producibility. There are other examples that are in the rules. I hope that these will suffice to illustrate the potential value of understanding, developing, and applying reliable technology. All right, so we say that reliable technology must be based on sound scientific principles, and it must be validated using evidence in the field. Well, there's more to it than that. We need a systematic procedure that we can count on as providing validation of a proposed reliable technology such that when we report reserves based on reliable technology to the Securities and Exchange Commission, we can have a high degree of confidence that the Commission will accept our reserves based on the reliable technology that we propose. So how can we go about doing this in a systematic way? Well, the broad answer to that question that I pose is we need to apply the scientific method. Details of this are outlined in an SPEE paper that I reference here. For those of you that would like to dig deeper, you can look at the details in this particular paper. This is another paper that Rod Sottle and I wrote and jointly presented. Here's the scientific method broadly to start with. First, we say, define the question. What question are we trying to answer? And then the second step, research that question and formulate a hypothesis. In this particular case, this means define the theoretical science that provides the basis for our proposed reliable technology. The third step, perform experiments. That is, apply the technology in the field. On the basis of that technology, reach conclusions, and then collect and analyze the data from this testing in the field of our reliable technology. So we now have data, which we'll analyze. The fourth step, interpret those data. And from that interpretation, draw conclusions. What did we learn about this proposed technology when we applied it in the field? Does it lead to the correct conclusion almost all the time? Document the results. Now, it may be that our original proposed reliable technology didn't always work. Perhaps we made too broad a claim. We claimed that it would work under more conditions than those in which it will actually work. In that case, step 5, we need to revise our hypothesis and claim that a certain, or at least adopt the hypothesis that a certain technology will work under certain conditions, but admit that it won't work under other conditions. And so we'll repeat steps 3 and 4 until we conclude that experience in the field actually does validate our proposed reliable technology. More specifically, how does this scientific method that I've outlined mostly in broad terms actually work in petroleum reserves applications? Well, what we need to do in these specific applications, we need to define how the reliable technology will contribute to reserves estimation. For example, we would like to be able to establish an oil-water contact using methods which allow us to go beyond just lowest known hydrocarbons. We would like to find where that contact really is. So we propose a method. We need to research the science behind this application. We can't just oppose a random method for which there's little theoretical backup. Whatever we propose needs to be based on scientific principles. But scientific principles have their limits of applicability. We need to determine in this application of the scientific method when our proposed technology is valid. And then we need to test in the field to validate the hypothesis and demonstrate that the requirements for our proposed technology have been met. And then finally, we need to document our results, and especially important, in this documentation, we need to include those conditions that are needed to achieve reliable technology. That is, establish what are the limits on successful application. As I look at some examples with you in just a moment on reliable technologies, I think I will clarify for you this final step in the procedure in particular. That's, in a nutshell, the scientific method that we need to pursue to validate our technology, but we still need to ask this question. Are there any further requirements? Well, I would say that we need to include all the test data in our documentation. We don't want to be guilty of selectively excluding some data. In the long run, that's going to cause questions about the consistency and reliability of our proposed technology. Not only do we not want to report reserves to the SEC based on cherry-picking data, just as important, we want to make sure that our proposed technology actually works and that this leads our company to correct conclusions which in the long run will lead to more profitable development of any resource under consideration. The second bullet is just as important. We need to keep the analysis that we're doing, the documentation of the results updated with new data as this technology is used. If we systematically keep track of what's happened with our proposed reliable technology, this could, in the long run, change our conclusions on the limits of applicability. They may be broader than what we thought initially. They may be more narrow than what we thought initially. And the best way to learn this is from applications in the field. The next question that we might ask is, in demonstrating reliable technology, what did the SEC really intend for us to do? There's a fairly lengthy discussion, a fairly complete discussion in the SPEE paper that I mentioned here. Let me just single out a particularly important quotation from that paper, and it's this. The SEC will expect persuasive empirical evidence that the application of the technologies has led to correct conclusions when applied in the same reservoir, in an analogous reservoir in the same formation, or in an analogous reservoir in another formation. Persuasive empirical evidence includes drilling results, that is, that when we drill based on a technology that says if we drill out in certain locations, we're much more likely than not to get economic producibility. All right, gather that evidence. We've drilled out there. When we drilled, did we find economic producibility as we claimed with our reliable technology? Now, these results should be in locations similar to the proposed proved undeveloped locations, or if we're applying the technology to located fluid contacts, we need to gather systematically the empirical evidence that supports the fact that yes, application of this technology does lead to identifying hydrocarbon water contacts the vast majority of the time. And then the final thing I mentioned here that the SEC expects, the sample size. The number of times we've tried the technology, that should be sufficiently large to establish that the conclusions are statistically significant. In other words, we can't try it once and it leads to the correct conclusion. We say, okay, this is reliable technology. We can't even try it 3 times and have 3 successes and claim that we have reliable technology. Sometimes in these discussions I'm asked, well, how many times do we have to try? Well, reasonable certainty arguably means something like 9 times out of 10 we are led to the correct conclusion. The SEC in its rules did not quantify this. What they said, if you look back at the definition I gave earlier, you should be reasonably certain if you're going to claim proved reserves. What does reasonably certain mean? Arguably 9 times out of 10 ought to suffice. 91 times out of 100 would be even more persuasive, but almost all the time the proposed technology should lead to the correct conclusion. We just want to make sure that we've tried it enough times that we can claim that we have a statistically significant size sample. I've been talking in generalities up to this point, as I recognize, so let's get down to some specifics now. Reliable technology has been proposed in the literature virtually ever since the SEC presented its modernized rules to the public. And so the question that we ask here is, what recent literature on reliable technology is available? In other words, what have people said in publications about technologies that they have tried and that they have found lead to correct conclusions the vast majority of the time? I've listed several examples on this slide. This is not an exhaustive list, but I think it's quite sufficient to illustrate what people have hypothesized and validated in the field, and then have been kind enough to propose to the industry that these technologies at least work in areas where the authors of these publications tried them, and they're suggesting to the industry that you might try these technologies in your reservoirs, and the suggestion is that they're likely to work there too, but you have to validate it in your reservoirs. So examples: use of seismic. Seismic can be used to establish lowest hydrocarbons, that is, hydrocarbon water contacts, which in turn can be used to establish the area that can be considered to be proved, that is, an area such that if wells are drilled in that area, they're going to be economically producible. Now, with the seismic work that's been published, limitations have been found. Sometimes seismic, under certain conditions, is a reliable way of locating the hydrocarbon water contact. Sometimes, under other conditions, it is not. The publications that are available here give the results of some experience in applications of this technology. I don't list paper numbers on this slide, but if you'll read the paper on which this entire presentation is based, and that paper number goes back to our early slide, if you read that paper, you will find references to the literature in which applications of these technologies and the results of these applications are described. All right, seismic, another use that has been mentioned in the literature and claimed as reliable technology, is using seismic for reservoir characterization to determine original oil in place or perhaps original gas in place in a reservoir, which certainly is directly related to reserves. Seismic can be used to define the level of uncertainty or the probability of success in reservoir studies. Another technology is dynamic reservoir simulation. There have long been differing opinions about just how reliable reservoir simulation is as a basis for estimating reserves, which are then reported to the regulatory authorities such as the SEC. And there have been some publications here which document conditions under which reservoir simulation has been found to be a reliable technology. And from simulation, it has been established that when certain conditions are satisfied, we can be confident that we can use simulation to establish ultimate recovery in a reservoir We can use simulation to establish with confidence the characteristics of our static reservoir model, particularly what is the amount of original oil in place within that reservoir. The third example that I mentioned here is one that, at least in my experience in talking with operators, is of great deal of interest and clearly very widely used in resource plays. And this technology is a combination of geological modeling and statistical methods which can be used to establish a proved area and the possible proved undeveloped reserves from wells potentially to be drilled within that proved area. This particular technology I'm going to mention a bit more as we proceed because of the widespread interest in this. This technology was proposed to the industry in the Society of Petroleum Evaluation Engineers, SPEE monograph number 3. Many of you may be familiar with monograph number 3. The authors in that monograph and in papers that that some of the authors have written about that sort of technology, they've said, we understand what the criteria for reliable technology are, and the particular method that we're proposing here satisfies those criteria. Many of those who authored the monograph proposing that technology have used that technology as the basis for some of their proved undeveloped reserves findings with the SEC. Since it's new, the SEC wanted to dig into the details of that technology, which they have done, and following sequences of comment letters, the SEC has ultimately said, we have no further comments, which is the SEC's method of saying, at least for now, we accept this technology as reliable technology. I mentioned here a fourth item, other technologies, because there's one I think that's particularly easy to understand, but which must be established based on evidence in the field in a given reservoir of interest or in an analog reservoir that it works. And this other technology is also intended to help us establish the lowest known hydrocarbons or the hydrocarbon water contact. And this methodology is the familiar use of gradients obtained by measuring pressures in the oil column or gas column in a well, measuring pressures in the water column in that same reservoir or formation, and finding the intersection point between pressures extrapolated from the oil column and from the water column, with that point of extrapolation meeting at what is alleged to be the true hydrocarbon water contact. Most geoscientists and engineers have been using this technology for many years for internal studies and have developed confidence in it. However, the SEC rules say very clearly lowest known hydrocarbons have to be based on what you found with the drill bit, unless you have reliable technology which establishes conclusively that you have hydrocarbons down to some particular lower level. You must establish that gradient method actually works. And when you've gathered empirical evidence that shows it works in your particular reservoir, then you can claim that as reliable technology. But if you don't have the backup data to show that that method has led to the correct conclusion the vast majority of the time, then you can be asked to remove reserves based on that lower contact from your books. When might that method fail? Well, it might fail to be persuasive if the quality of the data are not very good, as an example. All right, I said I would mention SPEE monograph number 3 in a bit more detail. I'm gonna do that now, but I'm gonna go beyond what's in SPEE monograph number 3. Now, as written, monograph number 3, it's a combination of geological modeling and other methods into one reliable technology. It's a package, and the proposal here. Well, the basic aim of the technology in monograph number 3 was to be able to expand proved undeveloped locations beyond immediate offsets. You recall that I said earlier the SEC limits us to immediate offsets unless we have a reliable technology that establishes conclusively that we can expect economic producibility at greater distances. All right, but it's a package as presented in SPEE monograph number 3. The package includes the geologic modeling and then the methodology for establishing what the PUD volumes are into a single package. We can restate this as a 2-technology process. We can claim on the basis of the methodology presented in SPEE monograph 3 that we can establish a proved area within a reservoir or within a resource play. We can do that, and then separately, perhaps using the technology that's proposed in monograph number 3, we can estimate the recovery from undrilled locations within that geologic area, but we can also propose as reliable technologies methods other than the method proposed in SPEE monograph number 3 as the basis for our reliable technology and use that. Let me provide more detail to explain where I'm headed here. The first step in the SPEE monograph number 3 technology is geological modeling. The idea here is we need to define an area with consistent geological properties, and within that area then establish the reasonable certainty or the certainty of economic producibility. So in the diagram here, the red circle outlines broadly the area of a resource play. Well, let's suppose that within that broad area, we have a smaller area, which is outlined here with the gray area. We study information available in that area, and we conclude that there's geologic similarity of rock properties, reservoir properties, geomechanical properties within that area. So we say this is our area with consistent properties, and then within that area with consistent properties, we look at information available from wells that have already been drilled, and those are the green wells here, and we establish from those wells the distribution of ultimate recovery from all the wells in the fields. Now, it takes more than 6 to do this, so please understand this is highly schematic. Actually, to do this for a given amount of dispersion in the reservoir, it's probably going to take on the order of 150 to 200 wells to be able to establish a statistically significant distribution of properties, because we're going to have to take that distribution and break it into several parts, and we need a reasonable number of wells in each part. All right, so we establish a statistical distribution of EURs, and then we say, okay, within this area, there are a number of undrilled locations that we can propose. And these are shown here as part of our project that we propose for this area using this SPEE monograph number 3 technology. We can claim on the average the proved undeveloped reserves that we can expect from drilling these wells. The authors of monograph number 3 actually extended this technology, and the figure that I show here is from a publication by some of the authors of monograph number 3, and the figure shows an area in the Fayetteville Shale, and the entire area shown here was established to have economic producibility. But upon further study, the analysts here found that the area could be subdivided into sub-areas with different amounts of proved reserves in these different areas. The best area had 1,089 MCF per foot of lateral length. The poorest of the areas, still economically producible, had less. So this methodology could be used to establish proved undeveloped reserves. Here's the question: can we use other methods to forecast recovery within the proved area? This monograph 3 methodology requires spatially independent statistical analysis to assign volumes to these undrilled locations. That is, the monograph 3 technology says we don't know what's going to happen to any particular well, because we simply assume that we have a statistical play, and we don't know on the basis of what's happened in one well what's likely to happen in other wells. But this deconvolved technology that we propose in the paper, this requires only a valid analogy, which then allows spatially oriented methods to be considered. That is, we can find areas of interest within resources in which there clearly is spatial dependence of results. That is, it definitely depends where we drill, and in those areas, rather than just assume that we're going to get on the average the mean EUR that we've established from all the wells in the area, we may find in specific areas that we can determine our proved undeveloped reserves by using information from nearest offsets, use nearby neighbors, and there's been technology proposed in the literature, and I give the reference here from a paper by Adonazi and others showing how we can do this. This is a perfectly valid example of reliable technology developed in another way. All right, what does the SEC ask of us in this quest for proving reliable technology, the burden that we have? And the SEC says in guidance that it has offered on its modernized rules This guidance is in a document available from the SEC called Compliance and Disclosure Interpretations. And to quote, the SEC says an issuer has the burden of establishing and documenting a technology that provides reliable results consistent with the criteria set forth in this definition number 25. That's the definition of reliable technology. This information should be made available to the Commission staff upon request in support of reserves estimates that the staff may be reviewing. So, what does this really say? In short, we got to keep records. If we propose to use reliable technology, we've got to have records that document that this technology has indeed led to the correct conclusions. Let me give you an example, a couple of examples from SEC comments as we near the end of this discussion. Here in this example, after a description of technology was provided by filer of reserves, the SEC staff asked about the recovery predictions. And so they asked the filer, who'd use something proposed to be reliable technology, please explain to us the revision history due to performance from proved reserves in your Barnett Shale play. Include a comparison between the median values as of year-end 2009 with median initial values for proved, estimated ultimate recovery, realized well cost, estimated well producing rate, time plots, decline curve parameters. A lot of detail here, but bottom line, okay, you've claimed this technology is reliable. You've used it to estimate reserves. Please provide the documentation for us that shows you how you arrived at these reserves that you claim to be based on reliable technology. Here's another one that's even more direct. Here the SEC asks about approved area. In part, your response 10 indicates a significant portion of your proved undeveloped locations are 2 or more offsets removed from producing wells. Tell us the statistics of your drilling history for such similarly situated locations, including the success rate by distance removed from production. You've claimed reliable technology at great distances, at greater distances than immediate offsets. Please prove to us that that when you've claimed reserves out of that distance and drill wells, that you in fact most of the time, like 9 times out of 10 or so, have achieved these kind of results. Now, a bit of guidance on these comment letters, and this is a quote from the SEC. The staff's comments are in response to a company's disclosure or other public information are based on the staff's understanding of the company's facts and circumstances. These letters set forth the staff positions. They don't constitute an official expression of the SEC's views. These letters are limited to the specific facts of the filing in question. They don't apply to other filings. All I'm saying here, and what the SEC is saying here, these comment letters are not official guidance. They really apply to only specific situations. Be cautious in using these comment letters as the basis for what you do. All right, let's wrap up with some quick conclusions. The publications that have been made on reliable technology have covered several technologies and targets, and I outlined several for you. Whenever in these publications a specific method to validate reliability was cited, the scientific method was the specific method that was used. Now, in other publications, the methodology did not, or the publication did not say the steps that the authors of this publication used in validating their technology, but it's pretty clear as we examine these, for example, in SPEE monograph number 3, that in fact the scientific method was used. we found no other standard methodology proposed in any publications proposing reliable technologies. Now, in some cases, reliable technologies proposed a combination of technologies. These can be separated into individually reliable component technologies like SPEE monograph number 3, which can be separated into a technology for establishing a geologically similar area in which there's economic producibility, but the way of establishing what the proved undeveloped reserves might be at any particular location might vary depending on the specific circumstances. And finally, SEC comment letters do confirm the need to develop a sound, well-documented case to propose a reliable technology and maintain good records on the results of applying reliable technology to establish proved reserves. I want to acknowledge Ryder Scott, which allowed us to use their SEC seeker application to look for SEC comment letters, which could be particularly helpful in this look at reliable technologies. And so with this, we're done with this look at reliable technologies. I thank you very much for your attention.
Today.
Susan?
Dr. Lee, thank you for your presentation today. We've enjoyed it. We're nearing the end of our time commitment, so I would suggest that attendees might contact you via email at Texas A&M if they have additional questions. And certainly we want to remind those who attended today that this is just part of a course that you are offering through SCA on the SEC reserves and resource regulations, talking about PRMS, and that will be offered in January and in May in Houston. And certainly contact SCA if you have questions about registering for that course. But we're so pleased to be able to have you today to share your information. And we also have another webinar scheduled with you on Thursday at lunch hour, identifying flow regimes, and it's a big assist for production forecasting. So we're looking forward to attending that webinar this week on Thursday. Thank you, everyone.